Kyle gets buckets.
How does he do it? A miracle?
No, projectile motion. Beyond making trick shots and getting buckets, projectile motion has been helping people achieve amazing things for hundreds of years.
These equations for projectile motion will be used to analyze how Kyle Singler was able to get buckets.
First, we went to Duke Chapel to perform some on-scene measurements. From this, we determined that the horizontal distance that a basketball traveled was 21.6 meters.
Then we found the height that the basketball was released from. The accepted height of the Duke Chapel is 64 meters from the base to the tip of the tower. However, since the shot was taken from the roof of the chapel, we can use visual analysis of this picture to determine how high Kyle Singler was when he took the shot. Based on this image, you can see the relative height of the roof, and using proportions, we can calculate that the height from the ground to the roof of the chapel is 53.768 meters. The height of a standard basketball hoop is 3.048 meters, and Kyle Singler is 2.03 meters tall. Thus, the total change in height is 52.75 meters.
Using this information, we can calculate the initial velocity the ball was released with.
First, we looked back at the video and noticed that when the ball was released, it only had horizontal velocity. This turns the calculations into a simple projectile motion problem.
Using these basic equations for projectile motion, we were able to determine that the basketball is shot with an initial velocity of 6.6 meters per second.
But how can we find the speed when the basketball enters the basket?
Simple. Energy. First, the ball starts out with both gravitational and kinetic energy. Given that the mass of a standard basketball is 0.624 kilograms, the initial sum of the energy is found to equal 354.8 joules. Since the law of conservation of energy states that energy can be neither gained nor lost within a closed system, by the time the ball reaches the hoop, it still has 354.8 joules of energy. Based on this, we can determine the final velocity of the ball to be 33.7 meters per second, which is about 75.4 miles per hour. The basketball is traveling as fast as a car speeding down the highway.
It must have been terrifying to have been the camera guy.
You're telling me, but I think I see something interesting here.
What?
As time passes, the angle the ball makes to the ground becomes closer and closer to perpendicular. Can it ever reach 90 degrees?
No, because even as the ball gains vertical velocity by accelerating towards the ground, it always has some horizontal velocity as well. In fact, when the ball enters the basket after falling all the way from the top of the Duke Chapel, it is still only 78.4 degrees to the ground.
So even if Kyle Singler were to throw the basketball off of, say, the Empire State Building, it wouldn't be able to reach 90 degrees?
Yeah, in fact we can prove it. Using these equations for final horizontal and vertical velocity and some basic trig, we can calculate that if Kyle Singler threw the same basketball off the Empire State Building with the same amount of horizontal velocity, it would hit the ground at an angle of 85.9 degrees. Get buckets.